Alright, ladies and gents, in this video I want to show you how to factorize polynomials. And once we factorize the polynomials, we want to identify what are all the roots or what are all the zeros, both complex and real, okay? And so you're going to be able to factorize the polynomials completely, first by graphing and applying the rational roots theorem, and then we'll be using some other algebra to solve and evaluate what values of x make this equation equal to 0. Okay? So first and foremost, I want to show you a little flow chart. Consider this step 1 through 6. Okay? So the first step I'm going to ask you how to do is, given p of x, given this polynomial equals to 2x to the fourth plus x cubed minus 5x minus 6, let's go ahead and identify all the real and complex roots, okay? So first, step 1, okay? You're going to identify the degree of the polynomial. Now this is real simple, right? You take the leading term, and you take, this should be the highest power of this polynomial, okay? So here's the highest power 4, so this is a degree 4 polynomial, okay? So for step 1, check. All we had to identify what the degree of the polynomial is. Now this is going to be very useful, okay? It's useful because what we can do is, we know how many zeros we're going to be looking for. Okay, so we know this is degree 4. And I'll write this down. Degree 4. What this means is we're looking for 4 roots. Okay, this whatever number that is, 4 zeros or 4 roots. Okay, we'll get into a little bit more explanation what a root is. Think of a root as any number, both complex or real, that makes this equation equal to 0. Okay? Let's go ahead and go to step 2, graph and identify the rational roots. Remember, these are zeros that look like fractions or could become fractions, okay? It can be rewritten as fractions. So let's go ahead and graph this. We're going to go to our graphing utility. We're going to go ahead and graph the equation 2x to the fourth and so forth, okay, that polynomial. And there it is, all right? Here's our polynomial. We have our first 0, right? Real 0. This is a real number. This is our polynomial p of x. And here it is crossing the x-axis at 2 points. The first one is at negative 1, 0. Negative 1, 0, I'm going to write this down. We have negative 1, 0. And the other 0 is at 1 and 1/2, or 1 and 5/10 and 0. Okay, 1 and 1/2, 1 and 5/10 and 0. Okay. Alright, great. You'll notice that there's no other places that this polynomial is crossing the x-axis. Right? I've zoomed to the expression, okay? I've zoomed in properly on my graphing utility. You may have to do this, right? Maybe you're only zoomed in on this section. You gotta zoom out and make sure you're able to observe all the places where the polynomial p of x crosses the x-axis. Alright, great. Step 2 is done, okay? Next step, we want to translate these zeros, okay? Translate these rational roots into linear factors. Okay, so let's go ahead and do that. So in a previous lesson we went through this expression. How do we go and rewrite this? Negative 1, 0 into a linear factor. Okay, how do we transform this into an expression that looks like this? A x plus b. Or it could be minus b, right? Well, the first idea was to rewrite our 0, we're going to rationalize our 0, and then take the bottom, whatever that bottom is, multiply it by x, okay? So we get 1 times x, and then we're going to add the opposite of this number, okay? So if we're going to add the opposite of negative 1 would be positive 1. Let's go ahead and write that. So here I have negative 1, we're going to add the opposite plus the opposite of negative 1 is positive 1, okay, plus 1. So this is our linear factor, x plus 1, all right, we can even rewrite this in an equivalent form, something that we might like a little bit better, as opposed to writing 1x, let's just write x plus 1, okay. So here we have written our factor, negative 1, and we've rewritten as a linear factor. Great. Our 0 into a factor. Great. Alright, next step, let's do it to the other one. To the other 0. We have 1 and 1/2, or 1 and 5/10, and 0. Okay, how do we do that? Same process, okay? We have 1.5. If you use your calculator, you can rewrite this as a fraction in improper form. This is 3/2 and 0. Okay, if you have any problems with that, look for the button on your calculator. I believe it's generalized D over C, something like this. This button will transform 1 1/2 into a fraction. Okay. Otherwise, it's good to know, right? What is 1 1/2 in improper form? From here, do the same thing. You can take the denominator, multiply it by x, 2x, and then you're going to add the opposite of the numerator. Opposite of 3 is -3. So let's add a -3. And there we go. We have our first factor and our second factors. Step 3, part B. Go ahead and divide the polynomial. We're going to divide this polynomial by both of these factors. Okay, both of these linear factors. How do we do that? Well, we can do that either synthetically, right? Synthetically, or using long division. Let's first remember rules for synthetic division. Okay, the rules go that in general, you want to use a polynomial of this form where you have x plus or minus some number, right? So to use synthetic division, I'll remind you, to use synthetic, generally you want a divisor in the form of x plus or minus some number a. Okay, in this case, we have x plus 1, so this works really well. X plus 1. So what we'll do is we'll write out the leading coefficients, or the coefficients of our polynomial. Note that I'm going to use 1 for the number in front of my x cubed term, okay? So I'm going to use these coefficients, 2, 1, -5, and -6 in my synthetic division, and then I'm going to divide through. Okay, my divisor is going to be the opposite of this number. Okay, so what's the opposite of positive 1, everybody? Well, it's -1. So let's divide -1 into my coefficients, 2, 1, -5, and -6. 2, 1, -5, and -6. Our summation bar. If you remember the algorithm, what you're doing is you're going to bring the first number straight on down. Okay, you'll rewrite it. And then you multiply by the divisor. 2 times -1 is -1. And then we add. 1 minus 1 is 0. Multiply by -1. You get 0. You add through. You get -5. And then we... something happened here. I made a mistake. Oh, good to make mistakes, okay? So we can recognize what our problems are. The problem here is that we didn't write our polynomial in standard form, okay? In the form I want is decreasing powers of x, all right? So we have x to the 4, x to the 3, and all of a sudden we have x to the 1. What are we missing? Well, we're missing x to the 2 power, okay? So we have to have our descending powers, and we've got to insert that into our polynomial expression here, meaning if I take all my coefficients again, if I'm doing synthetic division, you need 2, 1, 0, -5, and -6. So I'm going to include that 0. 0, -5, and -6. Let's try this one more time, okay? Bring the 2 down. 2 times -1 is -2. The sum here is -1. -1 times -1 is +1. The sum is 1. -1 times 1 is -1. Add these together, you get -6. Times, multiplied by -1, you get +6, and the sum is 0. Okay, great. So if this is a rational root, this should always work out. The remainder should always be 0, and you should be left with a polynomial with 1 degree fewer, right? So if this were degree 4, now we have a degree 3 polynomial where the leading term is x cubed followed by, oops. Yeah, that's right, x cubed, right? 3 is 1 fewer than 4, x squared plus 1x minus 6. Okay, so here's our new polynomial. Now we're going to do the same thing over, except this time we're going to divide by this. This will be our divisor, okay? And you're going to do this for however many times you have a 0 or a rational root, okay? So let's do this again.